Present, sir.
Okay. Adarsh Shinde. Adarsh Shinde. Ankita.
Present, sir.
Okay. Chandrasekhar. Chandrasekhar. Harshigowda.
Sir, present, sir.
Harsh.
Present.
Okay. Okay. Janvi.
Present, sir.
Right. Mahadev. Mahadev. Mohammed. Mohammed. Kirti. Kirti.
Present, sir.
Okay. Pikesh. Pikesh. Prajwal Gowda. Prajwal
Present,
Gowda.
sir.
Okay.
Present, sir.
Ramesh. Ramesh. Ratan. Ratan.
Present, sir.
Right. Rohan. Rohan. Rutik. Rutik.
Present, sir.
Okay. Rutvik Gune. Rutvik Gune. Sadashiv. Sadashiv. Sagar. Sagar. Sai Prakash. Sai Prakash. Samir Ahmad.
Present, sir.
Right. Sania.
Present, sir.
Okay. Sanjay. Sanjay. Sankalp.
Present, sir.
Right. Sanket.
Yes, sir.
Okay. Shiraj. Shiraj. Shivnanda. Shivnanda. Shraddha. Shraddha. Shubham.
Present, sir.
Okay. Sumit. Sumit. Suraya Banu.
Present, sir.
Right. Tejas. Tejas.
Present, sir.
Okay. Vivek. Vivek. Yamnappa. Yamnappa. गांवकर रजत रामचंद्र. गांवकर रजत रामचंद्र. मंजुनाथ. मंजुनाथ. प्रथमेश.
Present, sir.
Right. Joslino. Joslino.
Present, sir. Present, sir.
Okay. Okay. The last class I was explaining about the voltage divider bias, common emitter, voltage divider bias circuit. Let us continue an example on that. This is the example. All of you note down this example. Note down this example. For the circuit shown below, determine VCC. Determine VCC if AV equal to minus 160 and R not equal to 100 kilo ohm. Take beta equal to 100. For the circuit shown below, determine VCC if AV equal to minus 160 and R not equal to 100 kilo ohm. Take beta equal to 100. Note down this example quickly. This is a voltage divider bias circuit. R1 is 82 kilo ohm, R2 is 5.6 kilo ohm, RC collector resistance is 3.3 kilo ohm, RE emitter resistance is 1 kilo ohm. C1 is connected input side, input coupling capacitor, C2 at the output terminal, output coupling capacitor, and there is a bypass capacitor CE. Bypass capacitor CE. VCC is applied. VCC, the supply voltage is applied. Okay. We are supposed to find the value of VCC. We are supposed to calculate the value of VCC. What are the given values? First, when the problem is given, note down the given values first. AV is minus 160, voltage gain is given. R naught is 100 kilo ohm output resistance, and beta is 100. Beta is 100. So here, this is connected to ground. 5.6 kilo ohm, other terminal is connected to ground. Here emitter resistance 1 kilo ohm, other terminal is connected to ground. Noted down the circuit here. Okay. Right. Now here they have asked to find the value of VCC. Okay, it's a 6 marks problem. It's an examination problem, 6 marks. It has been asked for 6 marks. Here they have asked to calculate the value of VCC. VCC value should be calculated. We know that when we were discussing in the module 1, the method for finding the different voltages, right? There we discussed the exact method and approximate method. Two methods we have discussed related to voltage divider bias circuit. And according to the exact method, VTH, the threshold voltage, is given by the formula VCC into R2 divided by R1 plus R2. VTH is equal to VCC into R2 divided by R1 plus R2. This is the formula for the Thevenin's voltage, Thevenin voltage, okay, not threshold voltage. It is a Thevenin's voltage. It is given by VCC into R2 divided by R1 plus R2. Now here we are supposed to find this value of VCC, okay, VCC, right? If we want to find the value of VCC, okay, then what we should know? We should know VThevenin. R1 and R2 are given in the circuit. R1 and R2 are given in the circuit. We should first know the value of VTH. Okay. Now, how to find out VTH? VTH we can find out using the relation. That is, if we apply KVL, this portion of the input circuit, here it is a junction where we have the VTH. Between R1 and R2, it's a junction where we have the Thevenin voltage, right? So the current is flowing from the VCC, through R1 to the resistance 5.6K. Okay, similarly here it is splitting. Here the current splits. The part of current flows through 5.6K and the part of current flows through base to emitter junction of the transistor. That means the current is entering here 5.6K positive, then negative to the other side. A current entering is taken as positive, current leaving is taken as negative. Similarly here base to emitter junction, current entering is positive, current leaving is negative. Positive, negative. Base terminal positive, emitter terminal negative. Okay. Now similarly at the 1K resistance, emitter resistance positive, current entering, and the other side which is connected to ground, that is negative. Now VTH is the voltage at this junction. Okay, the junction of R1 and R2, it is VTH. Therefore, if we consider VTH, then here, are you able to see here, students? Are you able to see my face?
Yes, sir.
Okay, there is a power cut. That's why I'm asking. You are able to see my face, right?
Yes, sir.
Yes, sir.
Oh, right, fine. Now here there is a junction, so we have VTH here. There is VTH, so VTH is the voltage at the junction. VTH plus VTH, because negative to positive is plus VTH. Then as we come to the other side, positive negative here, positive to the base, negative to the emitter. So positive to negative, minus VBE plus VTH minus VBE, then positive negative minus IERE, emitter current multiplied by emitter resistance, emitter voltage. Okay, what we have here, KVL equation, negative to positive plus VTH, positive to negative minus VBE, then positive to negative minus IERE is equal to 0. Okay, accordingly, if we use that equation, right, here we have VTH is equal to VBE plus IERE. VTH minus VBE minus IERE equal to 0, or VTH is equal to VBE plus IERE. Therefore, VB is known, IE we don't know, RE we know, 1 kilo ohm, it is given in the circuit. IE we have to calculate. If we want to calculate IE, then the relation is 26 millivolt by RE, because RE is 26 millivolt by IE, or IE is equal to 26 millivolt by RE, right? Now here, if we want to find out IE, then we have to know RE first. We have to know this RE. Now how we can find RE? We have the relation for the voltage gain. AV is given by minus R0 parallel RC that divided by RE. The gain equation for the voltage divider bias circuit is minus R0 parallel RC divided by RE, voltage gain equation. We have discussed this in the previous class. Right here, they have given AV minus 160. It is given in the problem statement. Then R0 is also given. RC is there in the circuit. It is 3.3 kilo ohm. That divided by the emitter resistance RE. Correct. Now, if we apply this formula, then we will be able to find the value of RE. Find out the value of RE, students. AB is minus 160. That is equal to minus 100 kilo ohm into 3.3K divided by RE. Find the value of RE and tell me how much it is. The emitter resistance. The formula is AB is equal to minus of R0 parallel RC that divided by RE. AB is given minus 160. R0 is 100 kilo ohm. RC is 3.3K divided by RE. Find the value of RE. Calculate that. How much? How much you are getting? Yes, please. What is the answer? Who will tell me the answer?
19.97.
19.97 ohms exactly. RE is approximately 19.96 or 19.97 ohms. Fine. Now, once we calculated RE, then RE is 26 millivolt by IE, or IE is 26 millivolt by RE. Use this relation and find the value of IE. IE is 26 millivolt by RE. 26 millivolt, this divided by RE is, we have calculated just now, it is 19.97 ohms. Substitute that and find the value of IE, emitter current. Tell me how much is the emitter current. 26 millivolt by RE is the formula for IE. How much you are getting?
1.3 milliamperes.
1.3 milliampere, exactly. 1.3 milliampere. We calculated now IE. Okay. First, I explained you how to find the value, okay, using various relations, using various formulas. Now I'm explaining you how to get the value of VCC. Okay. Previously we went in the reverse direction. Now let us apply those formulas, okay, to get the next values. Now VTH is given by VBE plus IERE. Use this relation. VTH is equal to VBE plus IERE. VBE is 0.7 volts, it is fixed, plus IE is 1.3 milliampere. Just now you all have calculated, into RE, capital R it is. Capital RE. Capital RE is how much? Emitter resistance, it is 1 kilo ohm. RE is 1 kilo ohm. Substitute that and tell me the value of VTH. VTH is how much? Thevenin's voltage.
Two volts only, sir.
2 volts, right. Answer is 2 volts. Thevenin's voltage will get 2 volts. Okay. Now, once we found out the value of VTH, apply the formula. VTH is equal to VCC into R2 divided by R1 plus R2. That's a voltage divider rule. VCC into R2 divided by R1 plus R2. Apply this and find the value of VCC. Rearrange this for VCC. We get VCC is equal to VTH into R1 plus R2. This will get cross multiplied. That divided by R2. Therefore, VCC is equal to VTH is 2 volt. Just now we have calculated. R1 is given in the circuit 82 kilo ohms. R2 is 5.6 kilo ohms. This divided by R2, that is 5.6 kilo ohms. Calculate how much is VCC. 2 volt into 82K plus 5.6K, the whole divided by 5.6K. Tell me the answer. Formula is VCC is equal to VTH into R1 plus R2, the whole divided by R2. How much you all are getting? Janvi? How much you are getting? Harshigowda? Harshigowda?
Sir, doing, sir. Doing.
Okay. Kirti? Kirti? How much you are getting? Ratan? Birje? Rutik? Chopde? Rutik? How much you are getting answer?
Sir, 31.29 volt.
13?
1.29.
No, 13 or 31?
31, sir. 31. 31.
Correct. Exactly. 31.3. Approximately 31.2 volts. Fine. Answer is VCC will get 31.2 volts. Okay. So this is how we are supposed to find the value of VCC. If this problem statement is given, they may give you this problem in the form of a statement. They may mention R1 is equal to 2 kilo ohms, R2 is 5.6 kilo ohms, then RC is 3.3 kilo ohm, RE is 1 kilo ohm. Okay. Then they will give in the form of values, or they may give in the form of circuit. Okay. So you'll have to remember, if they give in the form of statement, right, they will mention as voltage divider bias circuit. If they give in the form of circuit, they will not mention which circuit it is. You have to identify that which circuit it is, right? For example, here the figure is given. Okay, we have to identify, you all have to identify which circuit is this. So this is the voltage divider bias circuit, because there is R1, R2, there is RC, there is RE, so it is a voltage divider bias circuit. Then if they are giving in the form of a statement, only the sentences, no figure, then they will mention clearly that it is a voltage divider bias circuit with R1 equal to 82, R2 is equal to 5.6, RC is 3.3, and RE is 1 kilo ohms, like that. Okay. Is this problem understood here? Is this problem understood?
Yes, sir.
Okay, right.
Yes, sir.
Fine. Next, we will take up one more circuit. It is emitter follower configuration. Here we will be developing the RE model for the emitter follower configuration. Okay. So sometimes they may ask in examination this emitter follower configuration. That's why I have taken this emitter follower configuration. In this emitter follower configuration, the input is applied through the coupling capacitor C1 to the base terminal. Input Vi is applied through coupling capacitor C1 to the base terminal. Output is taken from the emitter terminal. Note that. Output is taken from the emitter terminal through the coupling capacitor C2. Through the coupling capacitor C2. Okay. There is no collector resistance here. In the emitter follower configuration, there is no collector resistance. Okay. So which all circuits we have studied? We have studied fixed bias configuration, voltage divider bias configuration, okay. Then emitter bias configuration. This is not emitter bias. In emitter bias, this RC resistance will come. Okay, it is emitter follower. In emitter follower, RC resistance will not be there. Okay, there will be only RB and RE resistance. And one more we have studied, that is collector base bias circuit. Collector base bias circuit, that is there is a feedback from base to collector. Base to collector, there is a feedback. Collector base bias circuit. So these circuits we have studied. This is one more circuit, that is emitter follower configuration. In this emitter follower configuration, there is RB resistance, there is no collector resistance, and there is RE resistance. And input is applied to the base terminal, output is taken from the emitter terminal. Input impedance is Zi, output impedance is Z0. Input current is II. This is the figure which shows the emitter follower configuration. Input signal is Vi applied to base through coupling capacitor C1. Output is taken from emitter through coupling capacitor C2. AC equivalent circuit. How to draw the AC equivalent circuit? What is the rule here to draw the AC equivalent circuit? DC voltages should be made 0. Which is a DC voltage here? VCC. This is a DC voltage. We have to make it 0. The supply voltage, because it is a DC voltage, we have to make it 0 because it is a AC analysis. Right? Make it 0. Make VCC 0 and short circuit the capacitors. Short circuit the capacitors for AC analysis. If it is DC analysis, we have to open circuit the capacitors. Clear here? So accordingly, we will get this circuit. This is a circuit that we get here. We have the input voltage Vi, input current II, and the resistance is RB. The same what it is there in the previous one, RB. Why are we getting here? Because VCC is grounded. VCC is grounded, it is connected to ground, it is 0 volts. Therefore, RB comes in between base terminal and the ground. VCC is 0 volts. That means it is connected to ground. That means RB comes in between base terminal to ground. Therefore, here in this circuit, RB is connected between the base terminal to ground. Then what about the emitter part? Emitter, it is connected, okay, it is connected between emitter terminal to ground. RE is connected between emitter terminal to ground. This is emitter resistance RE is connected between emitter terminal to ground. Okay, the same it is. RE is connected between emitter terminal to ground. And what about collector? Let us see the collector. Collector is connected from the collector terminal to ground. It is shorted. Collector is just shorted to ground. VCC is 0 volts. Therefore, collector is connected to ground. That is what we can see here. The collector terminal is connected to ground. Now, if we look into this circuit, right? Input current is II. Input voltage is Vi. Input impedance Zi. Okay. Then output voltage is V0, which is collected from the, which is tapped from the emitter terminal. Then output current is I0, because according to our convention, we are taking the output current into the terminal, according to our 2-port convention. Okay, so I0 is taken into the circuit, into the terminal, output current. Then the output impedance is Z0. Emitter resistance is RE. If you look into this circuit, the collector terminal appears to be common between input section and the output section. The collector terminal is common between the input part and the output part, between input circuit and the output circuit. Hence, this emitter follower configuration is also called as common collector configuration. Remember, in examination, they may ask, explain the RE model of the emitter follower configuration, or they may mention, explain the RE model of common collector configuration, any of these two. You have to remember the alternative names of emitter follower configuration, that is, emitter follower configuration is also called as common collector configuration. Okay, they may ask in either of the two ways. Okay, either they may ask as emitter follower configuration or common collector configuration. Both are one and the same RE model. Okay. The terminal is common between input and output circuits. Hence, it is common collector configuration. The AC input voltage Vi. What is the AC input voltage Vi? If you look into this Vi voltage, this Vi is appearing between the base terminal and the ground. Vi, it is appearing between this base terminal. It is parallel path between base terminal and the ground. Therefore, Vi is VBE, this voltage VBE plus V naught plus V naught. Vi is V VBE base to emitter voltage plus the voltage Vi. Fine. Vi is VBE plus V naught. VBE is very less, 0.7 volts. It is negligible, hence it can be neglected. As compared to V naught, VBE is small. Therefore, we can neglect this VBE term. If we neglect this VBE, then we'll get V naught is equal to Vi approximately, or Vi is equal to V naught approximately. That is, output voltage at emitter terminal follows the input voltage at the base terminal. What this indicates, V naught is approximately equal to Vi. The output voltage at the emitter terminal follows, or it is approximately equal to the input voltage at the base terminal. Okay. Hence, the circuit is called as emitter follower configuration, because the output voltage at emitter terminal follows the input voltage at base terminal. Therefore, the circuit is called as emitter follower configuration. Equation 1, what is the equation 1? V naught is approximately equal to Vi. Gain equation is V naught by Vi. Gain equation is output voltage by input voltage, but V naught is equal to Vi. Therefore, Vi and Vi will cancel. We get 1. V naught is equal to Vi from the equation 1. The equation 1, V naught is equal to Vi. Substitute V naught is equal to Vi. Therefore, Vi and Vi will cancel and we'll get 1. That means gain for the emitter follower circuit is unity. It is 1 approximately. Now let us replace the transistor in the circuit by its RE model. Let us draw the RE model for the transistor circuit. Here note that we are not considering the output resistance R0. Okay, for simplicity purpose, we are not considering R0. R0 is less also in case of emitter follower configuration, hence it can be neglected. Output resistance can be neglected for simplicity purpose. This is how the RE model is drawn. RB is same between base terminal to ground. It is same whatever we have considered in the previous circuit from emitter, from base terminal to ground. Then this base to emitter junction, it is similar to a PN junction diode. PN junction diode, as we are discussing for the previous circuits, the emitter base junction is similar to PN junction diode. Therefore, it can be replaced by a diode. Again, the diode can be replaced by its AC resistance. So, if you are replacing the diode by its AC resistance, then we have the RE, small re, emitter resistance. But here we are getting beta RE. Okay. This I have explained in one of the classes how we are getting this beta RE, because we know that RE is equal to 26 millivolt by IE, right? RE, it is 26 millivolt. RE, it is 26 millivolt by IE. This is 26 millivolt. This divided by IE. Okay, this divided by IE here. Small RE it is IE. This is small RE, emitter resistance. Okay. Now IE is nothing but beta plus 1 into IB. IE is nothing but beta plus 1 beta plus 1 into IB, base current into base current. Okay. Now if I replace this IE by beta plus 1 IB, as beta is very large as compared to 1, therefore this I can write it as approximately equal to beta into IB. This is approximately equal to beta into IB. Right. For what we have here, I is approximately equal to beta IB. That means RE will be equal to 26 millivolt, this divided by what we have in the denominator? Yes, beta IB. Now, what will be the formula for IB? 26 millivolt divided by beta RE. Okay, IB will be equal to 26 millivolt by beta RE. Beta RE I will take to the denominator, IB I will take to the LHS. Therefore, IB will be equal to 26 millivolt by beta RE. I got the equation for IB. It is 26 millivolt voltage divided by resistance. What is the resistance? It is beta into RE. That's why here we are getting this beta RE here, and the current is IB. Okay. Then we have the emitter resistance between emitter terminal to ground. It is same as that of the previous. We can look into this figure. It is connected between emitter to ground, RE resistance. Okay. Then this is emitter terminal, this is base terminal, this is collector terminal. Okay. Emitter, base, collector. The base current and the collector current are moving into the transistor, whereas the emitter current moves away from the transistor, because we know that the emitter current is the sum of base current and the collector current. IE is equal to IB plus IC. Right? Therefore, base current and collector current are moving into. Yes, please. Any doubt? Emitter current is moving away from the transistor. The base current and the collector current are moving into the transistor, because IE is equal to IB plus IC. Okay. Therefore, here IB is moving into the terminal, into the transistor. Collector current is also moving into the terminal, into the transistor, whereas emitter current is flowing away from the transistor. Okay. Therefore, we have the collector current, and collector current is given by, what is the formula for collector current? IC is equal to beta into IB. For common collector configuration and for common emitter configuration, we are considering beta. For common base configuration, we are considering alpha. Okay. Here we have the IC is equal to beta IB. Right. What about the I0 current? It is into the terminal. Okay. It is into, because according to our convention, two-port convention, we know that I0 current is moving into the terminal. Then we have Z0, output voltage is taken across the RE resistance. That is positive, negative, V0. Okay. Then we are calculating the performance parameters, input impedance, output impedance, right? Then voltage gain, current gain. Okay. That we will see in the next class, right? These relations we have to derive here. The relation for input impedance, equation for input impedance, output impedance, voltage gain, and the current gain. Okay. So these things we'll see in the next class, right? In today's class, I discussed about an example. We discussed about an example on voltage divider bias circuit, right? And then we have discussed what is emitter follower configuration. Why it is called as emitter follower configuration? Because the output voltage at emitter follows the input voltage at the base, hence it is called as emitter follower configuration. And we have drawn the short AC equivalent circuit and then the RE equivalent circuit for the emitter follower configuration. Okay. Any doubts here? Any doubts? Any questions? Yes, any questions here? Suraya Banu? Any
Yes,
questions?
sir. No, sir.
Okay. Shubham?
No, sir. No, sir.
Understood?
Yes, sir.
Okay. Shiraj? Sanket? Sankalp?
Yes, sir. Yes, sir.
Understood? Yes, Sankalp?
Yes, sir.
Okay. Any questions? Any doubts?
No, sir. I will go through once again and I'll ask.
Yes, please. Go through. If you have any doubts, you can ask me anytime. Okay.
Okay, sir.
Right. Sania, any problem in understanding? Sania?
No, sir.
Clear, right? Today's topics.
Yes, sir.
Okay. Rutik, any doubts? Rutik? Kirti, any doubts here? Kirti? Janvi?
Yes, sir.
Any doubts?
No, sir.
Clear with the today's topics?
No, sir.
No. Clear or not? Understood or not? Janvi? Janvi?
Yes, sir.
Understood or not today's topics?
Understood, sir.
Understood. Any problem in understanding?
No, sir.
Okay, fine. Then we'll continue in the next class. Okay, just go through this. If you have any doubts, you can ask me in the next class, or you can message me, or you can call me. Anyways, right? You can clarify your doubts. Okay, thank you.